Hello, today is our first episode in the series of answering emails sent to our main email account, labcodemath@gmail.com, and today's email is from viewer Nicholas. Nicholas said the following: I follow you online, but have some pre-calculus questions after seeing AP Pre-Calc is available. Can you solve these two identities? I'm looking to remember the steps, and trig identities are difficult. Well, I agree as well that trig identities are quite something that a lot of students will have trouble with, especially when we're going to the next level on AP Pre-Calculus. So yes, this should show that, as an example, any question or work that is sent directly to the email, labcodemath@gmail.com. And so we will go over these steps of these two problems, the first of which is listed up there. So as a quick reminder is that when problems like this show up, of course, they're just telling you that point A will go to point B, again, mostly looking very different from each other. But your job as a student is to show all the work to get from here, mathematically and logically, to end up at the result that they want. Sometimes you can go backwards or forwards. It works either way, given that this is an equation. But usually, they expect you that you can show every step following the basic rules of mathematics, as well as the rules of trigonometry that you should have remembered, such that you can go from here all the way to there. So let's begin. Let's have a look here, right? We need sine squared of t as the final result, usually meaning that we don't like things like secant and cosines. We want to get rid of all those things because those aren't very helpful to us. So why don't we take a look at it this way? Why don't we have it so that instead of leaving things as secant, we can change everything to sine and cosine terms, as that's the term that seems like the most reasonable for us. So let's have a look here. If we were to swap instead, so showing an equal sign going that we're going to take the route down from the left side, showing that secant instead goes to 1 over cosine of t, like this. We could then try to see what this will look like in terms of all just cosine of t. So this might look even more complicated, but the idea is that we're getting closer because now we have everything in terms of cosine, which should help us start reaching somewhere closer to sine squared, because something in our minds that will show, of course, is that one way to get sine squared, especially if you have only cosines to deal with, is that we have our very basic trig identity, of course, being that if you have sine squared of t plus cosine squared of t, you will get a nice and even 1. This is an identity, one of the most basic ones, that students should memorize so that you have a reference to go off of, knowing that if we then set up, instead of this way, of sine squared of t of 1 being equal to 1 minus cosine squared of t, that could be a reasonable solution. So long as we match up this side of 1 minus cosine squared of t, mathematically that will be equal to sine squared of t, exactly what they're looking for. Usually, you should try to kind of bridge the gap in your mind as to what are some possible solutions that will look acceptable, while on the other hand, you're going to work with one way trying to reach those acceptable points and then seeing what the work will lead you to. Now, for many cases, getting it the first try isn't going to be that easy, but again, with enough perseverance and showing all of your work, this should be very easy to work through. So going back here though, we have all of this. We have 1 over cosine of t subtracted by cosine of t, but all of that is divided by 1 over cosine of t. Well, what can be done there is that instead you can change this, instead of just a fraction over fraction and a bunch of this nonsense, you can call this instead 1 over cosine of t minus a cosine of t. So all of this now, the entire numerator, is now divided by, because this big fraction bar is simply division, we can divide it by what was in the denominator as 1 over cosine of t. Now that's pretty simple, because now instead of dealing with fractions over fractions and dealing with which denominator goes where, if you change it simply to a division problem, you can then go and do some very simple fractional multiplication. Because when you're dividing a fraction, of course, that means you're simply multiplying by the reciprocal. So what we can do then, we can easily show that we have that same numerator, 1 over cosine of t minus cosine of t, and all of that will be now instead multiplied by, instead of divided by, a whole cosine of t. Okay? By dividing by a fraction, you're simply multiplying its reciprocal. So you flip the numerator and the denominator. And now we can do some very nice distributive property here. We can distribute that cosine of t being multiplied across both of them. And then we should start getting some simpler results. Of course, 1 over cosine of t multiplied by exactly its denominator will give us a nice whole 1. And we leave the subtraction there because we're distributing. And then a cosine of t times cosine of t is a cosine squared of t. And would you look at that? It seems like we've matched exactly what one of our endpoints were, a 1 minus cosine squared of t, because that came from the very basic trig identity of sine squared plus cosine squared giving me 1. So mathematically, we have proven that through these steps of work, that what we start on the left side can be shown to be equal to exactly sine squared of t. It really is just a change as to how things look, but this is indeed very doable with all the work showing and a little bit of remembering of our trig identities that this is very possible. So let's get to the second problem that Nicholas sent over, and we should work on that right about here. And so this will be problem number 2 that Nicholas sent over, where we have this whole fraction of secant of x minus 1 all over sine of x times secant of x in the denominator, and it will be equal to tangent of x over 2. All right, so this one is a little bit more challenging because there is a different set of trig identities dealing with something over 2. Those are known as the half angle identities. Okay. And there are ones that are equivalent for tangent, sine, and cosine. And so to recall here is that tangent actually has a couple of ones. So if they call it tangent of u over 2, that's a way of describing any variable over 2, then that will be equal to, mathematically, this is something that students just have to memorize, it's going to be 1 minus cosine of u over sine of u. But also, there's a different form that also works as well. We can swap it to sine of u this time on the numerator, and then we have 1 plus cosine of u in the denominator. Okay, so again, these are identities. Again, they're basically hardline rules for us that will help us usually move over from one side of this equation to another. So we need to keep both of these in mind, and having something there that can easily be recalled back to as kind of the final blow here, because this is indeed tangent of x over 2, matches the exact form as to the way these identities work. So forming any of our work from the left side into either these two forms will be an acceptable way of showing that the left side is indeed equal to the right side. So actually, because of the way that we can see here that we are only dealing with sines and cosines with the identity, we don't really like secants going up in there in the first place. So what we can do is that we can then first start off by going 1 over cosine of x. Again, we can swap all the secants over in terms of cosine, so that will be easier for us to keep track of as to what our progress looks like. So we have instead 1 over cosine of x subtracted by 1 all in the numerator, and then divided by sine of x multiplied by 1 over cosine of x in the denominator. Okay, so the same idea is going to happen though, is because we have a lot of fractions over fractions, very confusing. We have no idea what's going on. So why don't we do this? We can go and take that numerator, so 1 over cosine of x minus 1. And the same idea is that we can then divide it by all of this now in the denominator. And that big fraction bar is just a nice big divided by sign. And so we have sine of x divided this time by cosine of x like this, as they can easily combine into one nice fraction. Again, this seems a lot more doable because from there we can simply change it to that same guy of the 1 over cosine of x subtracted by 1. And then instead of dividing, we can multiply it now by flipping it into a cosine of x divided by a sine of x. This will be a lot nicer because with the multiplication, we can then go ahead and do good old distributive property across. We can actually leave the sine of x in the new denominator across, but just multiply that cosine of x across that new numerator. So by running some distributive property across the 1 over cosine of x minus 1, we will then end up with the result of cosine of x over cosine of x, now subtracted by a cosine of x. okay, as such being distributed, but then we still have that same denominator across all of them of sine of x. Now this looks like we're getting somewhere quite close to where we need to be, because by going cosine of x over cosine of x, that's a simple solid 1 minus a cosine of x. So that all stays the same, all divided by sine of x. And would you look at that, we've matched exactly what we needed to on this side to reach the tangent of a variable over 2. And because we matched that identity, we can simply run it to take us to prove that tangent of x over 2 is indeed the result of all of this that we have on the left side. Okay, so hopefully these two should be a good reminder as to how to run some trig identities. Again, you might not get it the first time as to how you can run this type of problem, but in any case though, it really just takes a few steps of perseverance and checking your work to make sure that you can meet the requirements that you need using the identities that should be reminded and memorized by you. So I hope to see that your journey in AP Pre-Calculus is a well one, as we can continue to answer any other questions again at the email labcodemath@gmail.com, and we can either answer them live through our live streams on Tuesdays and Thursdays, or over here on video form where we can do it all together on the blackboard. Hopefully that works, and we'll see you next time.